Every single time you book a flight or stream a movie or even just check the weather on your phone, you're tapping into this invisible, incredibly powerful engine. And that engine? It's a database. So today we're going to peek behind the curtain at this unseen architecture that, believe it or not, quietly runs our entire digital world. All right, let's get into it.
We're going to tackle this just like an architect would, building our understanding from the ground up. First, we'll see why getting the foundation wrong can be a total disaster. Then, we'll meet our building materials and our construction crew. After that, we'll go from a rough sketch to a full-blown blueprint, explore two totally different architectural styles, and finally, we'll see how a great design gives you the freedom to renovate down the road.
So, first things first, why all this focus on getting the foundation right? Well, because in the world of technology, a crack in your data foundation isn't just a small problem. It's probably the most expensive mistake you could ever make. Yeah, and this quote right here, it hits the nail on the head. Think about it. You can fix a simple bug in your app's code, right? That's like patching a crack in the drywall. But if you mess up the data architecture, the very bones of your system, you often have no choice but to tear the whole thing down and start from scratch. It's a complete catastrophe.
You see, the real trick isn't just storing data. If that's all we needed, a bunch of text files would work just fine. No, the complexity comes from managing it all. How do you stop information from getting corrupted? And how on earth do you handle thousands of people trying to buy the very last concert ticket at the exact same millisecond? That's where a well-designed database becomes absolutely crucial.
Okay, so let's move on and get our tools and materials in order. We're going to break down three core ideas that people often mix up, but they are fundamentally different things. We've got our data, the database itself, and the database management system. Everything starts with just raw data, but data by itself, it's kind of useless. This pyramid shows the journey perfectly. The number 10.5, that's just data. It means nothing, but add some context, like degrees Celsius, and suddenly it becomes information. Apply that information, and now you've got knowledge. Hey, I should probably wear a jacket. And over time, that builds into wisdom, like planning your whole wardrobe for the season. The job of a good database is to help us on that journey from raw, meaningless data to genuinely useful information.
So, to be super clear, let's define our terms. Data is the raw material. It's just a pile of bricks. It's the numbers, the words, the raw facts. Without any structure or any context, it's really just a pile of stuff.
Now, a database, that's the blueprint. It takes that pile of bricks, that raw data, and it gives it structure. The two keywords here are structured and interrelated. That's what makes a database different from, say, a folder full of spreadsheets. The blueprint defines how all the bricks connect to each other.
And to really see why this blueprint is so critical, let's look at what happens when you don't have one. What you're looking at here is a simple spreadsheet, what we'd call a flat file. See how Professor Petrenko's name is just copied and pasted for every single student in his group? That repetition, that redundancy, well, it's a ticking time bomb. And here's why that bomb is ticking. This setup leads to three huge problems, or what we call anomalies. First, the update anomaly. What if Professor Petrenko changes his name? You have to hunt down every single entry and change it. If you miss just one, your data is now wrong. Then there's the deletion anomaly. If the last student leaves group AI 102, poof, all information about that group and its professor just vanishes forever. And finally, the insertion anomaly. You literally can't add a new group into the system until you have at least one student to put in it. The whole thing is just incredibly fragile. So what's the solution? Well, it's actually beautiful in its simplicity. A proper database, a good blueprint, separates these things. You make one table for students and a totally separate table for groups. You only store the professor's name one time. This simple act of separation gets rid of all three of those nasty anomalies and makes the whole system solid and reliable. And that brings us to the final piece, the database management system, or DBMS. So, if data is the bricks and the database is the blueprint, then the DBMS is our construction crew. It's the actual software, things like MySQL or MongoDB, that does all the heavy lifting. It builds the structure, it manages who gets in and out, and it makes sure the whole building stays standing.
All right, so we've got our materials, we've got our crew, but how do we actually create the blueprint in the first place? Well, like any good architect, you don't just start laying bricks. No, the design process happens in very clear, very distinct phases. We design everything on 3 different levels, moving from the big picture down to the tiny details. We start at the conceptual level. This is the big idea. What are we trying to keep track of? Students and courses, simple. Then we move to the logical level. This is the detailed blueprint. Here we decide how we'll organize it, say with tables and columns. And finally, we get to the physical level, the nitty-gritty construction details. How is this actually going to be stored on a hard drive for the best possible performance? Now, to create that first conceptual sketch, data architects all around the world use a standard tool. It's called the Entity Relationship Model, or just ER model for short. You can think of it as the universal grammar for describing data.
And this grammar is surprisingly simple. It really just boils down to 3 things. It has nouns, which we call entities. These are the main things we care about, like a student. It has adjectives, which we call attributes. These are the properties of those things, like a student's surname. And it has verbs, which we call relationships. These describe how the nouns interact with each other. For example, a student enrolls in a course. That's pretty much the whole grammar right there. So once you have that basic idea sketched out, you have to make a really big decision. You have to choose your foundational design philosophy. And in the modern world, that choice usually comes down to 2 major schools of thought: SQL and NoSQL. But before we dive in, a little bit of history. The relational model, the one that uses SQL, it didn't just appear out of thin air. It was a genuine revolution that solved a ton of problems with older, much more rigid models from the 60s and 70s. Things like the hierarchical model, which was like a family tree, and the network model, which was a complex spider web. The relational model brought simplicity, and most importantly, it brought flexibility. Honestly, the best way to think about these 2 styles is to go back to our house analogy. A relational database, or SQL, is like a traditional brick house. It has a very strict, predefined blueprint, what we call a schema. It's built with tables, and it's incredibly strong, incredibly reliable. NoSQL, on the other hand, is more like a modern modular home. Its blueprint is super flexible, it's dynamic. You can add a new room or change the layout whenever you want. It's built for incredible speed and scale, but it might trade away some of that classic rock-solid structural integrity to get it. And this brings us to the ultimate payoff. The whole reason we go through all this careful architectural planning. Why bother with all these layers and models and blueprints? The answer is one incredibly powerful idea: the freedom to renovate. This freedom is called data independence, and it comes in 2 main flavors. First, you have physical independence. This means you can change the construction materials without messing up the blueprint. For example, you can rip out a slow old hard drive and plug in a super fast SSD, and the apps using that data won't even notice. Then there's logical independence, which is even more powerful. This means you can change the blueprint itself, like adding a brand new email column to your students' table, without breaking all the existing applications that depend on that table. It's huge. And this is the end goal. This whole layered design gives us the flexibility to adapt and the scalability to grow. It's what allows a massive information system to evolve as a business changes over years or even decades without just collapsing under its own weight. So there you have it, from a single meaningless number all the way to a complex, multi-layered blueprint. We've kind of journeyed through the hidden architecture of data. It's the unsung hero that structures all the information powering pretty much every single piece of technology we touched today. But this story isn't over. This architecture is constantly changing, which brings us to one final big question. As our digital world generates more data than we can even imagine, what's going to build our future? Will it be the rigid, reliable foundations of the traditional brick house, or the fast, flexible design of the modern modular home? Which architectural style is ultimately going to win?